short video talking about significant figures. Let me erase the stuff about the mole and get going with significant figures. So significant figures is I don't know. A lot of people complain about this and say it's hard. I don't really think it is. I think it's just tedious is how I would describe it. Annoying, and depending on what level of a science class you're in, this can be, how do I put it nicely, um, borderline unnecessary, right? Because like many of us at the high school level, even early college level, really don't do enough with quantitative analysis for this to matter. And if you're going, what does that mean? It just means that like the consequences of not respecting sig figs really doesn't catch up to you until you're in a uh, high level college classes. Certain labs maybe, but even then I would make the case that it's not super critical. But that's an opinion. And right now I have an army of professors about to break my door down about that opinion. But anyway, let's see what they are, right? You're here not for my jokes. You're here for the chemistry and the physics, yes? So, sig figs, shorthand, you can write dogs bark in the background. Sig figs, just a simplification of significant figures, basically is keeping track of the precision of measurement. Okay, so like in my opinion, I would say this is keeping track of precision in a measurement. Okay, that is not the all end all be all, but that's really why we do this. Okay, that's the reason that we care about significant figures. All right, and you say, well, what are they? Well, basically, anytime you take a measurement, so I measure something, and my meter stick, I measure it, and it says 1.12 meters. Okay, well, that's 3 significant figures. I can't represent that measurement without those 3 numbers, right? If I left off the 2, well, it's not the same measurement. If I left off one of the 1s, it's not the same measurement, right? You're like, yeah, obviously. Okay, it's obvious when the numbers are not 0. Okay, so like 55 grams, you're like, well, I have to have both 5s. I can't get rid of one of them, right? 5,128. I don't know, candela. I don't know why I always use candela. Yeah, you're like, hey, if I lose one of those numbers, it's a different measurement, right? That makes sense. Hopefully, you're like, yes, I'm on board with that. But what if I have a measurement like, I don't know, 100.15 grams? Okay. Now you're like, okay, we have zeros. And one of the biggest pet peeves I have about the way this is taught, the way people teach sig figs, is they're often like, oh, well, zeros are placeholders. And it's like, well, I mean, any number is essentially a placeholder. I mean, it represents the value in that scale, right? So like this measurement is saying what? It's saying, hey, there is 100. There are no 10s, no 1s, right? That's what that means if you think about it, okay? And then, of course, what? We have 1/10 and then 500s. That's what this means, okay? And I think you'd agree that every number in this matters. I can't get rid of one of the zeros. I can't get rid of one of the non-zeros, which means all of these numbers are significant. So you would say, oh, well, this is 5 sig figs, okay? And, maybe you're like, oh, that's not that bad, right? That's not that bad. Yeah, I would agree so far, but it's about to get a little bit worse, okay? So if I had the number, let's say, 100 grams, okay, this is where things get messy, because you might say, well, it's 3. You can't get rid of one of those zeros, right? You can't do that. Well, I can't do it this way, but I could take this measurement and put it in scientific notation. And how would I do that? It would be turned into 1 times 10 to the second grams. Do you notice how it's just 1, right? And you're like, oh, well, big deal. These zeros, this is the placeholder business, are stored in the exponent here, right? And what that means is that this number is only 1 significant figure. That's what it means, okay? And this has big consequences for other measurements, or I should say, let me back up, other calculations that you could do with this measurement, okay? So if you're doing like a lab and this was one of your measurements, it means that anything else you do with this measurement, so any calculations you do involving this measurement, you're going to be limited to one significant figure, which is not good. We don't want that. Okay, but it happens. Sometimes you say, "Hey, it's just the way the cookie crumbles." Okay, you might ask, "Does it really matter that much?" It can have big impacts. Okay, and we want to avoid those as much as we can. So you say to yourselves, 100 grams is one sig fig. I don't like that. Well, if it was 101, it'd be 3 sig figs, right? I need all three. Put this in scientific notation, 1.01 times 10 to the second. So you're like, okay, it appears that zeros that are maybe between non-zeros are significant. Yes, that would be correct. Okay, so like anytime there's zeros between non-zeros, they're significant. They have to be. Okay, so that's an easy one. You say, that's easy. I got it. If the zeros precede a non-zero. So this, of course, is before. Oh, here's my first non-zero. These would all be insignificant. Okay, because again, in scientific notation, this would be 1 times 10 to the negative fourth. Okay, I don't need the extra information here. Okay, only one sig fig. Okay, this measurement, incidentally, does kind of bug me because it is pretty precise down to the 10,000th, but it is what it is. Okay, so then what else can we do with this? All right, you say, how else can we get sig figs and make them messy or make them annoying? Hopefully I'm not making them annoying. Is maybe you have, I don't know, 0.00150, I don't know, meters. This would be 2 significant figures. And the reason for that is because we have, or I'm sorry, 3 significant figures. Sorry, I'm being a silly guy. 3 significant figures. Okay? And the reason it's 3 is we look for our first non-zero, which is the 1, then we have a 5, and then we have this trailing 0. That trailing 0 is an extra level of precision. Okay? And if you're like, how do you mean? If I said to you, how much do you weigh? And I say 192 pounds, right? That's 3 sig figs. Think about the difference between me saying this and me saying, oh, I weigh 192.000 pounds. Okay? If somebody said this to you, you'd be like, wow, you're really watching your weight, right? You're not just looking at the hundreds, the tens, and the ones. You're looking at the tenths of pounds, the hundreds of pounds, and the thousands of pounds. This is more precision, which means they count. Okay, they are trailing zeros after a non-zero, which necessarily makes them significant. Okay, as long as there is a decimal point, and that's probably something you've been noticing, is that the decimal point can have a big impact here. Okay, so this is 3 sig figs. How would I write this in scientific notation? 1.50, and yes, you should include that 0 there, times 10 to the negative third in this case. Okay, meters. All right. Yeah, those can matter big time, these trailing zeros. Okay. If you were to put rules down about sig figs, I mean, honestly, the biggest rule I would give you is, look for the first non-zero. All right, that's the first thing I would do. You'll look up rules, you'll see rules, 1, 2, 3, 4. You can do those, but I think this is your best bet. So look for the first non-zero. Okay, so for this number, where is it? It is, hey, it's right here. Okay? Then you say, is there a decimal? So if I come back here, I could say something like decimal. Okay? If there is, it means anything following this is significant. Okay? So if I'm like 10.00, hey, look, first non-zero's there. Oh, 1, 2, 3, 4 sig figs because there's a decimal. Okay? What about this? 1,000? Well, there's no decimal listed, right? So yes, this is significant, but these guys are not. Okay? You could also then say for your rules, sandwiched, which is a fancy way of saying, are the numbers of the zeros sandwiched between non-zeros. So like this is 1 sig fig, right? 1,000. But if I had 10,001, Okay, now these zeros are sandwiched, which means all of them would be significant. Okay, just be careful, because if you had 101,000, you might say, oh, that means all of them. There's no decimal. It just means these are significant, right? These are leading zeros, trailing zeros. If I put a decimal here, believe it or not, then they'd all be significant. Okay, leading zeros never are significant, so 0.0001750. These right here are not significant. However, these right here are all significant, okay, because they're following this decimal and following this first non-zero, okay? It's kind of a crash course over it. I hope it makes sense. Again, I think the big takeaway is here. I don't think this is stressed enough, to be honest. People just learn it, like, why am I doing this? That's why. And hopefully these examples are all making sense, okay? So hope you enjoy.